Well, greetings everybody. Let's look at this question, which I'm finding on my math lab. I'm given a function and a point, or I might think of it as a curve and a point on that curve. And I can verify that for this function or curve, if you let x be 1, you will indeed get y to be 1 over 7. It's definitely a point on the curve. And then it says use the following definition of the slope of the tangent line at the point x is equal to a to find the slope of the tangent line to this graph or curve at that point. So I see that and I'll use that the way it is, and let me show you how I would do it. Okay, so I have my work over here with the function and our objective, and here's that formula. And what we need to do is this. If I want to calculate the slope of this curve at that point, then in this formula, I need to let a be 1 and calculate the limit as h goes to 0. So if I take that formula and let a be 1, I'll get f of 1 plus h minus f of 1 over h. So I need to calculate the limit as h goes to 0 of that. Now I would do that in 2 steps. First step, I would reduce this formula. That's called the difference quotient right there. Okay? So I'll take f of 1 plus h, which you find right here, 1 over 5 plus 2 times 1 plus h, minus f of 1. If you put 1 in, you get 1 over 7. So 1 over 7 over h. Now I need to reduce this. And to do that, I'll need to do things like subtract these two fractions and then divide what I get as a result. So if I'm going to subtract these fractions, then I need to get a common denominator. That's how it works. So after a little reducing here and getting 7 plus 2h, I see that the common denominator among these fractions on top, which I'm going to subtract, is 7 times 7 plus 2h. I multiply this first fraction by 7 over 7, which is 1. I'm not changing it. I'm just multiplying it by 1 in the form of 7 over 7. And I multiply this one by 7 plus 2h over 7 plus 2h. Still, I'm just multiplying it by 1. I'm not changing it. I'm just changing what the denominator is. Now they have a common denominator, and I could subtract them. It's going to be 7 minus all of 7 plus 2h over 7 times 7 plus 2h over h. Okay? This subtraction distributes across all of that. So that's going to be 7 minus 7, canceling, and then a negative 2h. All right, so now I'm here. So for this part, I need to do some dividing. I want to give you an analogy to this part. I got to take negative 2h over 7 times 7 plus 2h over h. Just for analogy, that's kind of like this. That's like saying what's 1/4 divided by 3. Dividing fractions could be summed up like this. We say multiply by the reciprocal. So I need to take 1/4 times the reciprocal of 3. Maybe think of it as 1/4 divided by 3 over 1. What's 1/4 times the reciprocal of 3? It'd be 1/4 times 1 over 3. That's how you divide fractions. So that's 1 over 12. Now that's what I have here. I do the same thing. I take this top fraction and I multiply it by 1 over h. It's exactly like how I would do this over here. It just appears more complicated. That gives me this, and then those h's cancel, giving me negative 2 over 7 times 7 plus 2h. Okay, so that's the reduction part. I can't reduce it anymore. At this point, I'll go to the second step. Apply the limit as h goes to 0. Once you do that, if I apply the limit as h goes to 0 here, I will get the slope of the tangent line at the point as given. Okay? So limit as h goes to 0 of negative 2 over 7 plus 2h. I can calculate this limit by letting h be 0. That's a acceptable technique here. That gives me negative 2 over 49. That's the slope of the tangent line at the point 1 and 1 over 7. Okay? All right. So there would be my answer to part A. What is the slope of the tangent line at the point that was given for the curve that was given? Negative 2 over 49. You see it right there. The second part is what is the equation of the tangent line at the given point? Well, so I would do that in 3 steps, okay, with 3 concepts. First of all, the tangent line is what? It's a line. lines have the equation y equals mx plus b. So it would just be a matter of finding m and b. M's the slope, b's the y-intercept. Okay, well, I know the slope is negative 2 over 49, so that equation must take the form y equals negative 2 over 49x plus b. But I also know that the tangent line goes through the point that was given. 1 for x, 1 over 7 for y. So it must contain that point. So my third step, put 1 for x, 1 over 7 for y, and that gives you enough information to find b. b is 9 over 49. My equation for that tangent line, y equals negative 2 over 49x plus 9 over 49. See how I did it? I know the tangent line takes this form. I know the slope is this because I just found it, and I know it goes through this point. 3 things and you've got it. Okay? All right. So then I would select C for my answer. It's the only one that matches what I got. So that's how you do this. That's how you use this formula to calculate the slope of the tangent line. And part B, find the equation of the tangent line. Now, I want to talk a little bit about why this works. No calculus class would be complete without a little bit of a discussion about why this works. So I pose the question to you, how does the limit as h goes to 0 of f of 1 plus h minus f of 1 over h calculate the slope of the curve at that point they gave me? How does it do that? All calculus students should know. Okay? So imagine it like this. I've got the curve. This curve. F of x is 1 over 5 plus 2x. Okay? Now I'm going to dissect this formula a little bit. I would say this point is 1 for x, f of 1 for y. And this point is 1 plus h for x, f of 1 plus h for y. Okay? Now let's calculate the rise and the run between those points. The rise is f of 1 plus h minus f of 1. Isn't that how you do it? You subtract the y coordinates. Okay? Oh, that's that top part. See? That top part's the rise of these 2 points on the curve separated by h. Why do I say separated by h? Well, what's the run? This x coordinate, 1 plus h minus that one, 1. Oh, so the run's h. So that's the rise between these points, and that's the run. The separation between these points is just the number h. It's what gives them a little bit of distance between each other on the curve. So imagine this. All right, what this would be if I found the slope of there without the limit would be the slope of the secant line through those 2 points. Okay? What does the limit do then? I've already established this is rise over run. I got a point here, I got a point there. H is the separation between them. That's the rise over the run. That's the slope between this point and that point. The limit does what? Well, say I tell you that the h is the separation between the points. If I let h go 0, it pushes them together, closer and closer. H is the separation between them. This point gets closer and closer and closer to that point. What happens when it gets extremely close to it? Microscopically close. What was the slope of the secant line through the curve becomes the slope of the tangent line to the curve at the point where x is 1. Also, it could tell me the slope of the curve itself. Same thing. Okay, so do you see how that works? I get rise over run between 2 distant points on the curve. When the limit is applied, as h goes to 0, it pushes the points together. And it's because of that that it ultimately tells me the slope of the curve itself or the slope of the tangent line.